Today's lesson is on subtracting polynomials. As usual, there is a video guide to go along with this lesson. If you haven't printed the video guide, go ahead and pause the lesson, print the video guide, and then come back so that you can do the problems with me. Now, we've already talked about adding polynomials together, and we discussed that a polynomial is something that has more than two terms or more. Okay, so our polynomials today will have 3 terms in each one, and today we're going to be subtracting them instead of adding them. Now you'll find that the subtraction of polynomials is really very similar to adding polynomials. For adding polynomials, you need to put them in order from largest exponent to smallest, and then you just combine like terms. We will be doing the same thing with subtracting polynomials. There'll be one difference. Our first step, we'll add a step at the beginning, and then those other 2 steps are going to stay exactly the same. So the first thing that I want to do, though, is to demonstrate what we're going to be doing with polynomials with integers. So we've done subtracting integers before. That's in a previous lesson, -5 minus 4. And we learned that with subtracting integers, the best way to solve these is to add the opposite. Okay, so instead of subtracting 4, subtracting a positive 4, what we're going to do is change this problem. The -5 will stay the same, and instead of -4, we'll change it to adding the opposite. So instead of subtract +4, we will add -4. Once you change it, it's a much easier problem to work with. -5 plus -4, the signs are the same, so we add them, we get 9. Keep the sign of that bigger number, so it's going to be a -9. Okay, now, polynomials, we're going to do something similar. We are going to add the opposite. All right, now, to determine if a polynomial is subtraction or addition, you look at the sign in between the parentheses, okay? In our last lesson, that sign in between was an addition sign, okay? This time, it's subtraction. So what we're going to do is change this from a subtraction problem to an addition problem. Okay, so that's going to be our first step. If you want to write that down, step 1, change subtraction to addition. But you can't just say, oh, well, you know what, I like addition better, I'm just going to change that to addition and then do the problem, okay? Just like we did for the integers, we also have to change what's after the subtraction sign to the opposite. Now, when you do that, you must change everything in the second set of parentheses. So that's going to be step 2. Change all signs in the second set of parentheses. Okay? The first set of parentheses stays the same. Just like how our first integer, the -5, stayed the same, our first set of parentheses will stay the same. So 9 plus 11a to the 4th minus 7a to the 3rd all stays the same. I'm just going to change the second set, and I change all the signs, which means this is a positive a to the 3rd. I need to change it to negative a to the 3rd. This is a minus 10a to the 4th. I have to change it to plus 10a to the 4th. I must change all signs, which also means this -4 must change to +4. Once you do that, this is now an addition problem instead of subtraction. So we do the exact same steps that we learned in our last video, which means I put them in order from largest exponent to smallest. Well, the exponent of 4 is the largest, so I'm going to start with 11a to the 4th. Cancel that out so I remember. Now I changed this to plus 10a to the 4th, so that comes next, plus 10a to the 4th. Use the sign that you changed it to. After that, we have a to the 3rd power, so this is a minus 7a to the 3rd. This is also a to the 3rd power. Okay, so I'm going to write that as minus 1a to the 3rd. Those cancel. After that, I'm left with 9 and 4, so I'm going to put my positive 9. And this is now a positive 4 because I changed it. And now I just combine like terms. Okay? So a to the fourth, their letters are exactly the same. Remember, they have to have the same letter with the same exponent. Otherwise, you can't combine them. So my letters are the same, the exponents are the same. I can add those together. So 11 plus 10 is 21. Keep the letter the same, a to the fourth. Negative 7a to the third minus 1a to the third. Exact same letters, so negative 7 and negative 1. I have to add them because the signs are the same. And I get negative 8a to the third. So I've done the a to the fourths, done the a to the thirds. Lastly, I have 9 plus 4. Well, 9 plus 4 is 13, so that's a positive 13. I can't combine anything else, okay? The rest of these have different variables, so this is my answer, all right? Remember, there's no solving here because there's no equal sign. All we're doing is simplifying because that's all we can do. So your answer for number 1 should be 21a to the fourth minus 8a to the third plus 13. Now let's go ahead and take a look at number 2. Hopefully you've got those rules already written down. So looking at number 2, what we need to do is change subtraction to addition, okay? So make this problem easier to work out. So instead of minus, we'll make this plus. But you also have to change all the signs in the second set of parentheses. So there's my second set of parentheses. All the signs must be changed. So my positive 9x to the second becomes negative 9x to the second. My minus 9 becomes plus 9. And my minus x to the third becomes plus x to the third. Once you've changed the signs only in the second set of parentheses, then it just becomes an addition problem. You put them in order by their exponent. So the largest exponent that I see is x to the third. Okay, so I have a negative 3x to the third power. Well, I also have x to the third over here, and that's a positive 1x to the third. They don't put the 1, but I'm going to write it so I don't forget about it, okay? After that, x to the second, we have that right here, a minus 7x to the second. I also have a minus 9x to the second. Again, use the signs that you changed it to, okay? We changed it for a reason, so use that sign. And then after that, I do have an x to the first. Remember, there's a 1 there. They just didn't write it. So that's a positive 3x. And I don't have any more x to the first, but I do have a positive 9 that goes at the end. And from here, I just combine like terms. So x to the third, x to the third. Exact same letter, exact same exponent. I can combine those. Negative 3 and positive 1. The signs are different. You will subtract. Keep the sign of the bigger number. So 3 minus 1 is 2. It's going to be a negative 2 because the 3 is bigger. Keep your letter the same. So it's negative 2x to the third. So I've combined those. After that, I need to combine my x to the seconds because they have the exact same letter, exact same exponent. I can put them together. Negative 7, negative 9. They have the same sign, so I do add them. I get 16, x to the second. Keep the sign of the bigger number, so I need that minus sign. So that's those two together. Then I have a positive 3x, or a plus 3x, and a plus 9. Those are not like terms, okay? The 3 has the x, the 9 does not, so I can't put them together, all right? Which means I just bring them down, plus 3x and my plus 9. If you can't put them together, just keep them exactly the same and leave them in the problem. And this is in simplified form, negative 2x to the third minus 16x squared plus 3x minus 9. I can't simplify that any farther, so I am finished with problem number 2. For problem number 3, our polynomials are 7 plus 3b minus 7b to the fourth minus 7 plus b to the fourth plus 2b. All right, so our first step, again, is to just change subtraction to addition. and then change all of the signs in the second set of parentheses. So leave the first set alone. The second set needs to change. So instead of a positive 7, I'm going to make it minus 7. Instead of plus b to the 4th, I'm going to make it minus b to the 4th. And instead of plus 2b, I'm going to make it minus 2b. Again, make sure that you're going to use the signs that you changed them to, not the originals. So now I need to put them in order from largest exponent to smallest. So looking at the problem, my largest exponent is that b to the 4th. So I'm going to start with minus 7b to the 4th. After that, I have a negative b to the 4th, which I'm going to write as minus 1b to the 4th, just so I don't forget that there is a 1 there. So that's for this one. After that, I don't have b to the 3rd or b to the 2nd, so I need to go to b to the 1st power. This is a positive 3b, so I'm going to put plus 3b. And I have a minus 2b, so minus 2b. And at the very end, I have a plus 7 and a minus 7. Now that they're in order from largest exponent to smallest, I can combine like terms. So starting at the beginning, my negative 7b to the 4th minus 1b to the 4th, the variables with their exponents are exactly the same. So I can go ahead and combine those. Negative 7 and negative 1 is negative 8b to the 4th. After those, I have a 3b minus 1b. Or excuse me, 3b minus 2b. 3 minus 2 is 1. It is a positive 1b. But remember, anytime you have a 1 in front of a variable, you don't actually have to write it, and they won't write it. In simplest form, the 1 is not there. 1 times b is just b. So I'm going to leave this as just b. So those are together, and now I do 7 minus 7. Well, 7 minus 7 is 0. So I don't need it. These cancel out, and I'm left with negative 8b to the 4th plus b. This is our solution for problem number 3. Our last problem that we're going to do together, problem number 4, we have 12a plus 8a to the 3rd minus a squared, and we're subtracting from that 8a to the 2nd minus 12a to the 3rd minus 2a. So our first step is to change subtraction to addition, and then change the second set of parentheses only. Don't change the first set. So the second set, that positive 8a squared becomes minus 8a squared. Instead of minus 12a to the 3rd, we make it plus 12a to the 3rd. And instead of minus 2a, I'm going to make it plus 2a. After this, I can go ahead and put them in order from largest exponent to smallest. So first, if I look, my largest exponent is a to the 3rd. So that's going to be my first term, 8a to the 3rd. I do have another exponent of 3, my plus 12a to the 3rd. So I will bring that down next. After that, exponents of 2. I do have exponents of 2. I have this minus a to the 2nd. I'm going to write the 1 in. Remember, there is a 1 there. They don't write it. But I'm going to put it in so I don't forget. I also have a minus 8a to the 2nd. So I'll bring that down as well. After that, a to the 1st would come next. Well, I have a 12a, which remember has an exponent of 1. They just don't write it. I also have a positive 2a. And it looks like I don't have any whole numbers in this one, so now I can start combining. My a to the 3rd and a to the 3rd have the same letter, same exponent, so I can go ahead and combine those together. 8 plus 12 gives me 20, and keep the variable the same, 20a to the 3rd. After that, my a squared and a squared, I can combine those. So negative 1 and negative 8, the signs are the same, so I will add them. Keep the sign of the bigger number. So it's minus 9a to the 2nd. And lastly, we have 12a plus 2a. Combine the 12 and the 2, we get positive 14a. Okay, because those are like terms as well. This is my solution. I cannot combine anything else, because the exponents are different. So 20a to the third minus 9a squared plus 14a is our answer for number 4. At this time, go ahead and pause the video. I would like you to try problems 5 and 6 on the video guide on your own, and then you can come back and check your answers with mine. For problem number 5, our first polynomial is 11 minus 9k minus 12k to the 4th, and we were supposed to subtract from that 6 minus 12k to the 4th minus 6k. Now I did change my signs first. I changed it to addition, and I changed it to a negative 6, a plus 12k to the 4th, and a plus 6k. From there, I put them in order, negative 12k to the 4th, plus 12k to the 4th, minus 9k, plus 6k, plus 11, minus 6. And then I combine like terms. Negative 12 and positive 12, I can combine those because the letters are exactly the same with the same exponent. But negative 12 and positive 12 is 0, so I found that those actually canceled. So I got rid of k to the 4th altogether. It's no longer in my problem. Negative 9k and positive 6k, when I combined those, the signs were different, so I did subtract, and I kept the sign of the larger number, so I got negative 3k. And then 11 minus 6, I got positive 5. So my answer was negative 3k plus 5 for problem number 5. For number 6, our polynomials were x to the 3rd minus 8x to the 4th minus 7x, and I was subtracting from that 6x to the 4th plus 8x squared minus 9x to the 3rd. Again, the first thing I did was change to addition, and then I changed all of the signs in the second set of parentheses. So it became negative 6x to the 4th minus 8x squared plus 9x to the 3rd. After that, I put them in order from largest exponent to smallest. I got negative 8x to the 4th minus 6x to the 4th plus 1x to the 3rd plus 9x to the 3rd minus 8x squared and then minus 7x. Once they're in order from largest exponent to smallest, I combine like terms. So these have the exact same letter, same exponent, so I combine those together first. Negative 8 and minus 6, I got negative 14x to the 4th. From there, I combined my x to the thirds. 1 plus 9 gave me 10x to the 3rd. And then I found that negative 8x squared and minus 7x did not have the same exponent, so I could not combine them, which meant I left it as minus 8x squared minus 7x. I just brought those two down. So our final answer for number 6 is negative 14x to the 4th plus 10x to the 3rd minus 8x squared minus 7x. And that's the end of our lesson on subtracting polynomials.